Thank you for joining me again for this overview of the July 1st issue of the American Journal of Physiology, Heart and Circulatory Physiology's video table of contents, or from the editor's desk. Boy, do we have a lot going on in this issue. 3 outstanding reviews and 19 original research papers. I know you're excited, so here's just a small sampling. Healthy endothelial function is critical for adaptive responses to exercise. Here, Bender and Laughlin review differential endothelial phenotypes from vessels supplying slow and fast-twitch muscles. They further discuss hemodynamic sensitive signaling in endothelial cells. An important how-to review by Martin Gerdes proposes and discusses best practices for quantifying cardiomyocyte morphometric data. These are critical issues for everyone interested in cardiac remodeling in disease states and the effects of therapies. Third review by DeCavanagh et al. The focus is on the role of rapamycin-mediated mTOR inhibition during calorie restriction and its convergence with the angiotensin II signaling pathway. Importantly, the review discusses this area in the setting of age-related chronic disease. The review summarizes evidence for new molecular targets in the aging process and how mTOR inhibition modulates these pathways. Bradley et al. Characterized the effects of severe metabolic syndrome and obesity on dyslipidemia, myocardial oxidative stress, and endothelial nitric oxide synthase in obese swine. They also examined the effects of sustained-release sodium nitrite on coronary vascular reactivity and myocardial redox status in these obese swine subjected to critical limb ischemia. Following 6 months of an atherogenic diet, obese swine showed a decreased eNOS function and reduced NO bioavailability. Treatment with the slow-release nitrite compound reduced myocardial oxidative stress and increased antioxidant capacity. Coronary vascular activity also improved. A cell-based study, Koziel et al., addressed the issue of mitochondria-derived reactive oxidant species in endothelial cells. They focused on uncoupling protein 2 in isolated mitochondria subjected to high concentrations of glucose. UCP2 activity from human umbilical veins was significantly increased by high glucose. There was a greater increase in ROS generation by these mitochondria. The results indicate that endothelial UCP2 may function as a sensor and negative regulator of mitochondrial ROS production in response to hyperglycemia. Finally, Minnick and co-workers evaluated the role of adenosine receptors in the nucleus of the tractus solitarius in the attenuation of sympathetic nerve activity following activation of the cardiopulmonary chemoreflex. They hypothesized that A2A adenosine receptors inhibit the cardiopulmonary chemoreflex by facilitation of GABA release in the NTS. The responses to phenylbiguanide, which activates the cardiopulmonary receptors, was evaluated before and after pharmacological blockade of GABA receptors. The authors conclude that stimulation of NTS A2A adenosine receptors inhibits cardiopulmonary chemoreflex-evoked hemodynamic and regional sympathetic reflex responses via a GABAergic mechanism. Thank you once again for joining me on this trip through the table of contents. These short videos are reaching more people every week. I hope you find this informative and would love to receive your feedback. Please let me know how these videos can be improved or changed in any way. Feel free to email me or Kara Hansel-Keehan, our managing editor, with your thoughts. See you in 2 weeks, and don't forget to send us your best work now.